Welcome to Cybersecurity from Scratch, Episode 7, Web Enumeration and Fuzzing. For this episode, we're going to start out talking about some of the foundational web technologies that the internet utilizes. We'll then talk in a little bit of the abstract what the overall objectives are for enumerating a website, and then we'll get into how fuzzing can be used to accomplish this. Finally, we'll dive into, for the meat of the episode, some of the red team tools that are used to actually accomplish enumeration, and then we'll talk about, on the blue team side, how we can apply the lessons learned to make that enumeration more difficult. Before we talk about web enumeration, let's make sure we're all on the same page with some of the technologies that the internet uses. So first, when you're trying to initiate contact with a web server, your browser will issue what's called an HTTP request. Usually with client traffic from a browser, this takes two forms. Either you're issuing what's called a GET request, which is a simple asking for information, where you give a URL, the server gives you the page back that corresponds to the URL, and that's that. Or sometimes you have what's called a POST, where you're actually sending information. This is usually if you're logging in or submitting some sort of e-commerce purchase or something like that. Anytime that the client is giving information to the web server and the server is acting on it, that's going to be using a POST. On the server side, there's then a receipt of the HTTP request, and the server will act on whatever that information is. If that's a GET request, it will look up the page. If it's a POST request, it will store some information in the database or do whatever. The key idea is that the server is then receiving the message. It will then formulate an HTTP response, where the server is responding usually in HTML, which is sometimes augmented with JavaScript, and cascading style sheets, or CSS, to form a response body. It will also respond with a response code that lets the client know what's basically the characteristics of the response that it's receiving. For example, if you give a 200 status code, that means that everything is nominal, you're getting pretty much what you asked for. But if you, for example, receive a 404 code, then whatever the response body is sort of explaining that, well, we didn't have what you're looking for. Like that 404 is saying, I don't have what you want. This is not something that you can get from the server. And then finally, the client will render the response. So the client browser will take that HTML, that CSS, and the JavaScript and put it all together to make a functioning web page. And now, usually in the modern internet, this will involve additional calls to the server, as the JavaScript is asynchronously calling back to the server to do things. But generally speaking, it's all built off of these HTTP requests, where the client browser wants something, the server then passes it back. Now, of course, the vast majority of users have no idea that their browsers are issuing these GET and POST requests. It's just something that's happening automatically. So when you enter a URL into a browser, what's happening is this GET request, like the one that's displayed on the screen here, is being generated. The top line is pretty straightforward. You're telling the server, this is the resource I want, please give it to me. The host request is telling which host you're trying to address. So for example, if you're trying to access a domain or a subdomain, that information would be in there. You identify what the machine that's contacting the server is. In this case, it's Firefox. You can tell from this Mozilla user agent string here. You tell what information is accepted back, for example, which language, what encoding, and so on and so forth. HTTP POST looks a lot like a GET request, except you also are encoding arguments down at the bottom here, where whatever elements in the form that is being submitted are encoded and sent up to the server. Now, in this case, I picked a relatively straightforward example where you're simply logging in. So you have the login, you have the password, and this WP submit, which is WordPress's way of saying this particular post request is an attempt to log in. However, you can have much more complicated things. For example, an encoded image or something like that. You can bundle a whole lot of information up in an HTTP post. One of the early challenges in defining how the internet was going to work was figuring out how to stack different user requests on top of each other. All by itself, HTTP and HTTPS are stateless. That is, each connection or each GET request or each POST request is not correlated with a previous request. And so there needs to be some way for the server to know that the person who logged in on some prior request is the same person who's then asking for some restricted information later. And the way this is accomplished is with a cookie. So the server will allocate a cookie to a client who's connected so that when the client then passes back that cookie, the server can take the cookie and say, oh, that's, Steve, he's connected from that computer before, and now I can give him whatever he's asking for. This is particularly why it's important with e-commerce and whatever to secure with HTTPS, because if the transmission is intercepted, even if you don't have login information in that request, if you have that cookie, someone can steal the cookie and they might be able to then steal your session with the server. So when we say a session, what we're referring to is a group of interactions with the server, with an e-commerce site, whatever. The idea is that you, having logged in, are initiating a session, and that goes on until you explicitly tell the server, like, I'm done, I'm logging out, and then the session is over. But even if you aren't authenticating, a lot of times servers will store session information just so that it can tell that, say, you enjoy browsing to a particular page more often or whatever, and it can customize the content. Now, cookies are an important part of the attack surface, as they often include information that can be modified, and sometimes it's something that has absolutely nothing to do with your session information whatsoever. So we'll see as we do different CTF exercises throughout this series, different places where cookies can be modified and inspected to change the server behavior. Personally, I like using the cookie editor plugin for Firefox. It's a great way to just go in and see what cookies are out there. Just for example, I went into CNN's cookie set just when I was preparing for this episode, and I found that they had my latitude and longitude coordinates in a cookie, which is really strange. I don't know why they need that information, but they do, and that's a cookie that is stored in my session with CNN, so go figure. Anyway, it's a good idea to inspect cookies both for the sites that you're using generally, because you can see what information's out there, as well as if you're building a site, it's a good idea to make sure that you're keeping track of what cookies you're issuing to make sure you're not exposing information that you don't want to. There are a couple of key objectives in the enumeration sequence for a website, and it can be a little more complicated than other services because websites are by their very nature a little more complicated. So the very first step is identifying ports and services on a host server, and you want to identify domains and subdomains. This overlaps largely with the basic enumeration that we saw before, where you use nmap and just establish what's running. But next you need to go a step deeper and say, what are the assets available on this web server? So what are the pages, what do they do, etc. And then from there, begin to understand what the tech stack is underneath the website. So what the server technology is, what databases they're using, what plugins they might have configured, etc. Then you want to ask, so to understand the technology, could this be based off of a template? Because if this is a template, you might have inherited a CVE from the previous creator. And then finally, even if all the other things look great, are there any configuration errors that just open the site up to some sort of attack? You want to enumerate all these things, and that will help stage for establishing a foothold. Fuzzing is a technique where you spam an interface with random, invalid, or varied data to figure out what the program does under the hood. In the context of a web application, usually this involves using a word set or a character set and modifying HTTP GET and POST requests to sort of figure out what the functionality is by injecting these words or characters or whatever to see if you can get the website to do something unexpected. Just for example, if you have some sort of input that the website would take, like a form or something like that, you could inject or fuzz that interface to see what characters might make it return an error for you. And then from there, you can start building your understanding of what kind of error handling is under the hood, and that then goes on to how to exploit it. We'll spend a lot of the rest of this episode talking about fuzzing and how we can use different tools and techniques to enumerate the website. The very first step in the process is identifying services, so we start out with an nmap scan, just like we do with regular enumeration, and from there we can follow up with later analysis. Now, of course, multiple web services are possible per server, so you don't want to stop with the standard port 80 and port 443. Port 80, the convention is to have unencrypted web traffic, or HTTP, and with 443 to have HTTPS, or encrypted traffic. So when you type in HTTPS and then the domain, what you're really telling the browser is, I'm just going to assume that it's on port 80. And when you have HTTPS, you're saying, I assume it's port 443. To change this default port assumption, follow the domain with a colon followed by the port number. So for example, if you're trying to get to a Tomcat server, the default port is going to be 8080. So you would say, myvulnerabledomain.com:8080 to go to that default Tomcat port. Now, other web services will have non-standard ports as well that sort of vary by service. Now, if you're doing a capture the flag exercise, one of the more popular techniques is to hide a number of different web servers on the same host. So port discovery and enumerating these sites is a really important part of the process. Often there's extra tricks in there where, for example, one of the services will only be available internally. So the attacker first needs to breach an initial line of defense, get inside the local firewall, and then enumerate again to find another web server. Enumerating the domain and subdomains available for a particular organization and site are important both for general service identification, so you can find web servers and print servers and all sorts of stuff like that, but it's also important for identifying different behavior for a website, so it's a key part of that web enumeration process. Servers will respond differently depending on the domain and subdomain, depending on their configuration. And particularly in capture the flag exercises, it's a common trick to have your server respond completely differently to, say for example, admin.box or whatever. And so finding out that identity is a key part of what you need to do to solve the puzzle. So the first tool in the arsenal is, of course, the DNS zone transfer, which almost invariably does not work in this day and age. Most people are wise to it, but every once in a while something can slip through. SSL certificates are often issued too widely, and so the server can tell you, just reading the certificate, what domains and subdomains it's valid for. Simply reading through a web page can also give a lot of context clues. Often there will be, in a nice, clean, human-readable format, some reference to a subdomain. That's real easy. Or sometimes it's embedded in the HTML itself. If there'll be a link to another resource, or you're importing, some JavaScript or CSS from another domain, there's all sorts of stuff that can happen in there to kind of give away what's being pulled in. And then finally, the more advanced technique, if you can't find any references to a subdomain but think there might be some, you can fuzz for it. We're not going to get into that right now. We need a little more advanced knowledge of how to use some of the tools to do that, but it's definitely an option. And hang on for one of the tutorials that's going to be coming up in a later episode for some real deep dives in how to use fuzzing tools to accomplish that objective. Personally, I'm a big fan of using Dirbuster, which is a GUI-based fuzzing tool that does basically the same thing as GoBuster, but it's got a nice UI. By default, it does recursive searching, and it has a whole lot of other advanced configuration features that make it a little bit more flexible. One of the first ways of enumerating a website is to check the robots.txt file. So this is always included at the root of the domain, so you'd have, for example, wikipedia.org/robots.txt. And this would then provide instructions for a search engine on how the automatic crawlers should address the website, specifically saying, don't go here, you may go here, and so on and so forth. And this can provide a nice convenient map of what the different resources are on a website. And often, if there's something that the website owner doesn't want a robot reading, they might not feel great about a hacker reading that either, and they've just provided a roadmap to get to it. So that's one of the first resources you can check. It also, a little bit of operational security, it makes sense to write a robots.txt file in a way that maybe doesn't give away too much information about which specific resources you don't want a hacker getting to. The first fuzzer we're going to talk about is GoBuster, and you can use this as well to discover assets that are available on a website. What it does is pretty straightforward. You essentially give it a word list of directories or files that you want it to test. You give it a URL, and it sort of goes for it. Basically, it will take the URL, it puts a slash, and then puts whatever the string is from the word list, and blitzes through that word list to identify any resources that appear to be there. So there, you can see in the default output for GoBuster, it responds to code 200. Everything is nominal to the not authorized code, and so on and so forth. Of course, you can customize this. You can tell it with a -s flag that you only want, say, 200 responses, or you want a 500 response, which indicates there was some sort of internal error. You can customize that behavior a little bit. Now, a note, if you're doing pen test training or capture the flag exercises, one of the standard word lists that it's just sort of expected that you'll know how to use on Kali Linux is located at user shared dirbuster word lists directory list lowercase 2.3 medium.txt. That usually is going to work out for you pretty well if you're doing a basic capture the flag exercise. Personally, I'm a big fan of using dirbuster, which is a GUI-based fuzzing tool that does basically the same thing as GoBuster, but it's got a nice UI. By default, it does recursive searching, and it has a whole lot of other advanced configuration features that make it a little bit more flexible. So for example, if we want to do just a basic scan, we can give it our URL here. And we can give it a word list. In this case, I'm going to use one of the standard word lists that is pretty much ubiquitous for capture the flag exercises. This directory list 2.3 medium. And say I want to do some more custom things. Like, let's take a look at the advanced options. So something that we can do is we can set it up to authenticate if necessary, at least with basic HTTP authentication. We can configure it to have a user agent string. So this is in the HTTP request what the client is using to identify itself to the server. So in this case, it's telling the server that it is dirbuster, but if you want to be a little sneakier, you can tell it to tell the server that it's Firefox or something like that. You can also configure it to run through a proxy in case that's necessary. So for example, if you're doing an assessment of a network that say has like a front-facing portal, but then you're scanning some sort of subnet behind it that can only route through that front-facing server, and you manage to get a proxy in that front-facing server, you could use these settings to accomplish that. So let's go ahead and start off this scan. We tell it to start. And I personally like this tree view display here, because as things are discovered, you can see them crawl in. Now note, this is going to be a lot slower than GoBuster. It is doing recursive search, and it's just a little more overhead, but personally I like the tool. Another great tool that's out there is called wfuzz. wfuzz can do it can fuzz almost any part of the HTTP request, but particularly looking at it for content discovery, it's very powerful because it has a lot of functionality to allow it to filter out information. So one of the weaknesses with GoBuster and dirbuster is they're reliant largely on the server response code to filter out bad traffic. Now, a lot of times a server might be misconfigured and it will say, you know, hey, I don't have this resource, but rather than saying that with a 404 code so that the client knows that it's a bad request, then it'll respond with a normal 200, and only a human reading it can understand that, well, that resource I want isn't actually there. So wfuzz allows you to say that I want to hide whatever the response is by the number of words, by the number of lines, by the number of characters returned, etc. And so you have a whole lot more flexibility to adapt when the server has been misconfigured and doesn't respond to the correct code. Here's a little bit of wfuzz in action. So in this case, we're going to be using it in the same manner as GoBuster and dirbuster. However, it really can be used in many more ways. Fuzzing arguments, fuzzing subnet names, etc. Essentially what you're looking to do is put this fuzz, capital F, capital U, capital ZZ, in whatever position in either the URL that you're looking to fuzz or in some of the arguments. So here's just a basic example. Personally, I like to use wfuzz from Docker because that way you're always getting the latest. And in this case, I've configured it to filter out any file not found errors. So 301s, 403s, etc. So if it finds the page but you're not authorized or anything like that, it'll show up. So in this case, I'm just using vulnweb as my test source. And you can see here that it's detecting the admin directory, the CGI bin directory images, and so on and so forth. It's a very powerful and flexible tool. One of the next tools in the checklist is wget. This quick tool identifies the technologies used in the website. So whatever the server-side version is, whatever the client plugins are, etc. It'll try to get you a list of all of those different technologies, the language, the server version, etc. And that's a really great way to start looking for applicable CVEs. It's really simple to use. You just say what web and then the domain, and it just sort of does its thing. Many websites are templated, and so whoever is using that template is going to inherit any vulnerability. Oftentimes, you're not aware of the vulnerability when you start using the template, but later on something is found. The template names are often something that's human readable. Sometimes it's in the comment of the web page. So looking through the web page, both just what's presented and what's in the comments is really useful. And then simply by searching for the CVE, you can find out what's available for that particular template. Now, often the template owner isn't going to tell you what the version number is, but sometimes that version number is hidden in a license file. So one trick that can be done is, if your enumeration didn't identify that license file, you can go to the GitHub page of that template, figure out where the license file is, and then you can kind of get around that directory obfuscation and find out where the license file is. Go look it up in the live site, suddenly you know what to look for. So let's see how a templated website could go horribly wrong. So we're going to take on Hack the Box's system buff today, which is 10.10.198. I've already done an Nmap scan, and from that scan we can see that port 8080 is open. So we're going to take a look at that in our web browser. We pop over, and we see some sort of gym management software. Let me start tabbing around the system, seeing what it's made out of, looking for context clues, and we see this is interesting. It was made with Gym Management Software 1.0. Wonder what that's all about. Ooh, that's not good. Looks like there's an exploit for it. So we can see the ID is 48506. We'll just remember that. So if we want to pull it down to Kali, we can do so. And we scroll down. Looks like it's a nice, easy Python script. Just give it a URL and bam. Takes care of itself. So let's go ahead and do that. So we're going to pop over back here to Kali. Use the search exploit -m flag, which we remember from before. We give it the ID. We've got a copy locally. And let's try to fire it off. Wow, that was easy. I've got a shell. Now with all that other information identified about the website, let's look at how it's configured. Because after all, your software is only as secure as you configure it to be. Nikto is a great tool for identifying configuration weaknesses. However, Nmap is also valuable, as the script equals vuln argument will apply any applicable vulnerability scripts. And oftentimes you'll pick up things like default or weak passwords or stuff like that. Although we'll get into what the air quotes stuff like that really means as we talk about specific weaknesses that you're looking for. For now, let's just talk about the weak password thing. So a little bit of capture the flag hint, admin will work way more often than you think it will. Just as an example, I was doing a time challenge, and I was absolutely certain that I had to get the creds for this particular website to allow me to get code execution. And so I found a SQL injection on a different website running on the same host, managed to sort of fish around in the file system and find the configuration file that was being used for the credentials for this other website. 2.5 hours of work later, I found out that the creds were admin. So bit of a capture the flag hint, just try out admin. It works way more often than you'd think. And a lot of times that's either the capture the flag box creator's way of saying, this isn't really meant to be that hard getting into the website, or potentially, this really isn't meant to be an attack vector. Go focus on whatever other technology you're supposed to be learning in the exercise. There are two Linux tools which are really useful, and you'll want to be using them in your enumeration as well as just kind of using Linux in general. They're really useful tools. wget is the first. You say wget and then the file you're trying to download, and it'll just plop it right there in the current working directory, and you're ready to use your file. Curl is a little more flexible, where you say curl and then the name of the resource you're trying to get, and right there in your terminal window it will supply the text that you're looking for. So particularly if you're looking for some JSON object or something like that, it will give you the the text you're looking for right there. You can also pass in the -o flag, and it will write whatever it's receiving into a particular file. So you might be thinking, well, if I have wget, then why do I care if curl can output to a file? Well, sometimes you're using a new distro of Linux that hasn't been configured the way you're used to, or you're doing a CTF challenge where the guy is really mean and just likes to mess with you. There's all sorts of scenarios. It's just another toolkit to have in your arsenal. And then finally, the other cool thing you can do with curl is you can use the non-standard HTTP actions like put and move. So we're not going to get too much into these because they really don't come up too often, but every once in a while you'll find a scenario where you can use put, which allows you to essentially upload a file to a server, or you can move, which allows you to move a file from one point to another on a server. Now, almost never are these arguments actually going to be valid. The vast majority of the time they're disabled by default. No one in their right mind would want them open and available to anybody on a web server, but sometimes it happens, and sometimes you'll see that in a CTF challenge. Our next tool is Burp Suite. This one's one of my favorites. Basically what it is a tool that allows you to set up a proxy server and route all of your web traffic through that proxy, and then intercept, analyze, and modify the traffic. So the cool thing is you can, if you're issuing an HTTP post request, capture that request in your Burp Suite and then modify it however you please to fuzz the interface to detect some sort of behavior. For this next demonstration, all you need to have is Burp Suite, the Community Edition installed, and Foxy Proxy for Firefox, which allows Firefox to route traffic through your proxy. And it's a nice, easy way to just kind of one-click turn it on and off and use Burp Suite. So let's see Burp Suite in action. To try it out, we're going to first make sure that our proxy server is running. So we fire up Burp Suite, and we can see here under the Proxy Options tab that it's listening on port 8080 and will proxy traffic through there. So then what we're going to do is go back over to Firefox, and using our Foxy proxy, go to the Burp Suite proxy, which if we take a look at our options, that is basically aiming an HTTP proxy at port 8080. All right, so we're fired up and ready to go. So what we want to do is intercept this login request for our WordPress and just see what we can do. So we do that request, and we've intercepted a post. So we can see that we want to log in with admin right here, and with password right here, and a whole bunch of other arguments. So let's go ahead and forward that along. And we can see in the History tab the post request going through. So when we go back over, we can see it's waiting for the response. And nope, looks like I didn't have the right password. Darn. Okay. So what am I going to do about that? So there's a couple things I can do with Burp Suite. The first of those is I can try Intruder, which is a module that allows essentially brute forcing of passwords within a website. So we're just going to keep it simple for now to give you an idea of what Burp Suite can do, and do some more advanced stuff later. But high level, what you can do is you can change your username to, I know the correct username, so I'm going to plug that in. And then right here in the password field, I'm going to add a marker. And what Burp Suite is going to do is iterate over a list of possible passwords I'm going to give it, and put those into the position indicated by that marker within the post request. And then if it receives a correct page saying that we logged in, we know we have the right password. So let's give that a shot. Let's go put some bogus passwords in here, followed by a real password. Now, the free version of Burp Suite only allows you to do sort of a slow test. So you wouldn't use this for a real penetration test, but for capture the flag exercise, it works great. So here we are starting up. And we can see here that I didn't manage to guess the password with this request. So we can see that the length is the same in each of these responses, and if we filtered through the HTML below, we'd see it's denied. However, if the intent of this particular exercise was to return a login page, what we would see then jumping out at us is the length would be different. And so you can just scroll through, see where the length is different, and there, you've got the password. So a lot of CTF exercises will do that. Back to the proxy history tab, we're going to get to another really cool feature that Burp Suite has. So if we find a post request that, say for example, we suspect there's something nefarious we can do with one of the cookies, or we just want to play around with the arguments, we can right click and send to repeater. So then in repeater, we have this request and response window. So, say for example, we just want to change the host string. Like we think, for example, that there's some domain that it might respond to, like sub.domain.com or something like that. Fire off the request. And it's thinking. And the server will get back to us and populate the response over here. See? And in this case, didn't really change much. Oh well. So what we're going to do as we get to more advanced concepts, at like looking at cookies and looking at some of the inclusion attacks we can do, SQL injections and that kind of thing, this will be one of the key tools in our arsenal that we'll use for probing the interface and seeing what kind of vulnerabilities there might be. Let's talk a little bit more about fuzzing, and specifically some of the things that we can fuzz with wfuzz. We'll get into more advanced details on how this works as we get into some of the later tutorials, but just to give you a flavor and to kind of get you started with enumeration, these are some examples of things you can do. For an HTTP GET, it's relatively straightforward. You just have the word fuzz in whatever thing that you want to fuzz. If that's the argument for a particular request, it's nice and easy. Now for an HTTP post, it's still pretty straightforward. You can use the -d flag, which basically gives the body of the post arguments, and then you include the word fuzz just like you would with another GET request. And then also cookies are available too, using the -h flag to specify either the name of the cookie or the value of the cookie. You can fuzz both of those. So wfuzz gives you a whole lot of flexibility. Let's turn to the blue team side and apply some of this knowledge to figuring out how not to get hacked. We're going to have an entire episode later on passwords and password security, but for now, let's specifically talk about some of the basic web controls that you need to take. The first is, please change the default password. Most good programs these days will require you to pick a new password or do something like that, so there just is no default password. However, many products still ship with one. Please change it. Please. Also, one of the things you can do is timeout on repeated failures. So for example, if you try to log in too many times and fail, then that user account is just blocked. That kind of defense is effective against stopping something like the intruder attack that we saw earlier, where if you have, say, 3 failed attempts within a couple seconds, then that account is just locked until someone comes along and unlocks it. And then finally, you can delay response in a situation where it's not practical to lock an account. That way it just takes an attacker an obscenely long period of time to guess the passwords. Still not as great as doing a lockout, but it's better than nothing. Also, you have to watch your routing rules. Say, for example, that you have a website where you are hosting some sort of resource that people can get to, and what you do is you require, before the server will render a link to the assets, you have to require that the person is logged in. If they're not logged in, they don't see the link. You're secure, right? Not at all. One of my buddies actually made this mistake. He was running a website where he had a bunch of resources for a role-playing game, and he thought that he could just have a password blocking the link to the resources page. When I was helping him assess the security for that, I pointed out that, well, if you can guess the name of the resources behind that link directory, you can just enter the name of the link, and suddenly you're there. So fortunately, he was able to patch it, and it was just a dumb game for college, so it didn't really matter a whole lot. But the stakes can be a whole lot higher. For example, there was an e-commerce website a couple of years ago that I was taking a look at, and I actually noticed that they had this defect where they had a certain set of resources that you could download for free, and then there was a paywall to make you pay for the downloads for some of the older resources. Sort of you get a few things for free, and then you pay in if you want some of the other resources. However, they didn't actually have the server checking that you were authenticated before you downloaded those, so if you were able to guess the naming scheme for the older resources, you would be able to download them. Of course, I disclosed this, they fixed the problem, and everything was fine, but, if somebody less scrupulous found it, maybe they would be not getting the money that they deserved. So the key lesson here is make sure that your server authenticates the individual resources and not just controlling how you render the links to access those resources. GoBuster and those other enumeration tools can be used to basically spam the website, and if you can kind of sort of guess what the naming scheme is for the thing that you're trying to get to, you can probably get to it. It's just a matter of time, and eventually you'll find what you're looking for, and that can be really costly. We also want to give appropriate, read sometimes kind of useless error messages. End users don't really need to know what's going on with internal system functions, and outsiders really don't need much of anything. So say, for example, that an end user submits, I don't know, something like a payroll form or something like that, and there's some sort of formatting issue, or something doesn't validate correctly, or whatever. All they really need to know is the information required to fix the problem. Definitely don't give them a stack trace to show them exactly what's wrong in the code. That can be put in a log file, that can be stashed somewhere that someone who can use that information can retrieve. Just make sure that the information is appropriate to the end user. And for an unauthenticated user, somebody from the outside, they really don't need to know much of anything. So this can be a problem if, when you're returning error messages saying either a resource doesn't exist or you're not authenticated and you're not able to see this page. If they're not authenticated, then giving them a difference between a 404, a file not found, versus a unauthorized error will tell them what resources are out there, and they can use that information to infer other things. So, maybe consider how those error codes are being used. Also, definitely don't give version numbers to people who don't need them. Troubleshooters can check the logs, they can check other ways of seeing what the system baseline is. Your end users really don't need to know what all those plugins are, and they certainly don't need to be reading license files and stuff like that they can use to construct a vulnerability profile of your system. If you do have a page that has to convey that some resource is inaccessible, just also know that it can be human readable without having a filterable length. This will confound the wfuzz example that we showed earlier, where if, for example, the error page, it is returning a code 200, so the set page is saying everything is nominal. It's just saying, hey, I can't give you that resource. As long as it's the exact same length every time, an attacker can still filter that out and use that as a heuristic for attack. If you throw something variable in there, just for example, you could have a little HTTP or HTML comment, and then just have that comment be some randomly generated string of random length, then suddenly that becomes way more difficult to filter. Now, there's other settings in wfuzz that can be used where, say, for example, instead of filtering on the number of characters, you filter by the number of lines, so you got to throw in some carriage returns and other stuff like that to confound it. But there are things that you can do to make fuzzing a little bit more difficult. There are other things that we can do to slow down enumeration. So if you have human-readable URLs, those are easily guessed URLs, which means that your website is easy to enumerate. So, for example, if you have resources that are linked in, unless you have a really good reason for having the URL be human readable, maybe don't have it be human readable, especially if it's being linked to from some sort of other content where someone can't just look at a page that's on the public-facing side or the unauthenticated side and use that to infer a URL for a hidden resource. Even just putting simple suffixes and prefixes onto directories will eliminate default word lists. Now, of course, someone can come along and construct a custom word list, but that's extra steps that need to be taken, and it just sort of slows down the process. Remember, the idea isn't that any one of these steps individually puts up an ironclad defense. The idea is to just put every little bit in there to slow the attacker down. Another thing you can do, it's very simple, is check the user agent string. Like if you see someone hammering your website with dirbuster or gobuster or anything other than a valid client, then don't respond. You can just drop the traffic. There's no need to respond to that. And that also will slow things down, as a lot of very basic attackers won't know what the problem is. They'll just give up and go home. Now let's talk about the template for your website. So you're going to build a new website, and you're not going to reinvent the wheel because you're smart. You're going to look around and see that someone else has done the work before. You're going to take what they did, make sure it has the right license. Your boss loves it. The client likes it. Everybody is super happy. The story doesn't end here, though. You forget that the site is templated, because after all the functionality works, everything must be great, right? Unbeknownst to you, somebody finds a CVE against that template. Now, your patch plan is probably geared around the web server, the operating system, and so on and so forth. So maybe you're even meeting all the boxes you need to be compliant with your patch plan, but you're not patching your template. And then you get hacked, and all is not well anymore. So whether you're using WordPress, whether you're using, some custom thing like the gym management software that we saw in the demo from earlier, please keep your templates updated. This can be a real pain, especially if you're doing custom code modifications afterwards, and that all has to be taken into consideration with your risk posture. Because after all, if the template isn't being updated anymore and somebody finds a CVE, then you're patching that other guy's code, and that's just an expense that you're going to have to bear. So really consider the full risk trade there, and look at using something more well established. For example, with WordPress, it has this excellent framework so that if there is a CVE discovered against WordPress, which really happens all the time, however, it's also not that big a deal because you can simply update WordPress, and all of the custom code you're using is probably part of a plugin framework so that you're not relying on adaptations to the core WordPress client. So using something like that that's very well established and tailored for what you're trying to use with support for extensions is a much smarter choice than just kind of going with some random option off the internet. Now, if I have one thought to wrap up all of this, it's please test your own exposure. If you have a public-facing website, someone else is going to test it sooner or later, and really, it's better if you test it and find your own problems and fix them. So all these technologies that I've shown in this episode, how to enumerate a website, really you should be looking at what your own exposure is. Look at it from the offensive perspective, look at it how an outsider would, and really see, preferably engage a pen test team to actually try out your own defenses. And really encourage your own developers to be testing along the way so that things don't pop up at the end. In our next episode, we're going to take a step further beyond enumeration and start talking about how attackers get a foothold in web servers. Specifically, we're going to look at file inclusion vulnerabilities. First, we'll talk about what the heck a file inclusion vulnerability actually is and how people will find it, and then what you can do about it and make sure that you don't get hacked.